I said, thank you everyone for joining. This is a webinar put on by University of Toronto and Georgian Bay Forever. It's water pollution comes from the tiny fibers in your clothes. So the three presenters that we have today is myself, Brooke. I am the project coordinator at Georgian Bay Forever. I manage the Phragmites eradication program and the Divert and capture, the fight to keep microplastics out of our water. Then we have Lisa and Dorsa joining us from the University of Toronto. Lisa works on the effects of microplastics on animals that are part of the Great Lakes. In her work, she better understands how microfibers impact fish and invertebrates through physical and chemical processes. Dorsa is an undergrad student working in the Rockman Lab at University of Toronto. She's a double major in ecology and biology, and she works on quantifying microfibers emissions in the wastewater treatment plants. So just to kind of start this presentation, I want everyone to look around the room. I'm sure you see a lot of single-use plastic items destined for the landfill. Did you know that almost every piece of plastic manufactured since the 50s is still in our environment today? You see cleaning products, toys, cosmetics, takeout containers. A lot of these products are made for our ease and our convenience, but every year, Canadians throw over 3 million tons of plastic waste, and many of these items that we use to fill our lives with convenience have alternatives and sustainable solutions. So this is kind of an overview of what we'll be talking about today. We hope that you learn about plastics, microplastics, and microfibers, and that you'll learn about the pilot project happening right here in Ontario and challenge yourself on how to reduce the amount of single-use items that you currently use as a consumer. Again, just a reminder, if you do have questions, we'll have about 10 to 15 minutes at the end. So just put those in the chat box. So Georgian Bay Forever, we are a charity dedicated to scientific research and public education on Georgian Bay's aquatic ecosystem. Our mission is to protect, enhance, and restore our aquatic ecosystem of Georgian Bay by funding accredited research on water levels, water quality, and ecosystems. Our partnership with the University of Toronto started in 2018 when we were both interested in researching and learning more about microplastics in the Great Lakes. Later, Dorsa will go over the pilot project in Parry Sound and share the preliminary results that we are seeing. But to start, Lisa is going to explain to us what microfibers and what microplastics are. So over to you, Lisa.
Thanks so much, Brooke. Hi, everyone. My name is Lisa Erdle, and I'm a PhD student at the University of Toronto, as Brooke mentioned. Before I get started, I just wanted to say that there are so many important issues that are currently occupying our attention. And today, on June 4th, I just wanted to mention that I and my lab, we stand in solidarity with the peaceful protest in the Black Lives Matter movement. And I wanted to really just thank you all for coming today, because often environmental and social justice issues intersect. So thank you for being here, and I hope that you also show your support in your own way for this movement. So I'm a scientist, I'm a researcher, and I research the effects of pollution on the Great Lakes. But before I jump in, I wanted to tell you a little bit about my background and connection to Georgian Bay. I was extremely privileged as a young kid to get to spend my summers on Georgian Bay at our cottage. I loved the water. I would spend all of my time on the beach and swimming and playing with my two younger sisters. And when I think about Georgian Bay, I think about clean sand. I think about clean water. And in my mind, this environment is pollution free. But what I didn't know then, and what I know now, is that the water of Georgian Bay is not pollution free. It is contaminated with tiny microplastics. Many of them are so small that they are invisible to the naked eye. Next slide. Thanks, Brooke, for switching. Many of these microplastics are microfibers. And in fact, microfibers are the most common microplastic on the Great Lakes. And as a biologist, I know that it's really this small stuff that can be some of the most harmful, because they can easily get into the food chain at almost every level. Next slide. Microplastics are found around the globe, and often they concentrate in these ocean gyres due to wind and ocean currents. Many of you may be familiar with the Great Pacific Garbage Patch or some of these floating islands of trash, twice the size of Texas. What might be surprising, though, is that the concentrations of microplastics in the Great Lakes are as high or higher than some of the highest concentrations recorded in the ocean. And that's because these garbage patches are not floating islands of garbage. It's not something you can walk on and stand on. There are these concentrations of these small microplastics. And in the Great Lakes, because we're so close to a human source of these microplastics to the environment, we sometimes have order of magnitude higher than some of the highest concentrations in the ocean. And this is also true for Great Lakes fish, where we're seeing concentrations of microplastics in fish that are much higher than the ocean. Next slide, please, Brooke. So how did this all begin? Well, you all know this, but the rise of plastics really began in the 1950s, and the convenience, durability, flexibility, and low cost has made plastics a really popular material. This is a picture from Life magazine in 1955, and the first sentence of this article is absolutely priceless. It says, "The objects flying through the air in this picture would take 40 hours to clean, except no housewife need bother." So obviously we've come a long way, and we're starting to get rid of our plastic lifestyle and also some of these very outdated gender roles. Next slide, please. Also, this was a period that had the rise of new materials and new technologies for clothing. This is the time when polyester rose in popularity. Dacron was DuPont's new material, which we now know as polyester, and Orlon was nylon. This is also around the time of the electric clothes dryer. Next slide. Plastics are so popular that over 8,000 million tons has been produced. And as Brooke said earlier, most of this has been discarded. So this graph, it shows how much goes in use. So currently we have around 2,500 million tons of plastic in use, but really over half of plastic that has ever been produced has been discarded. A small amount has been incinerated, a small amount is that bottom loop and recycled and going back into secondary plastics. But really, I hope what this shows is that most of the plastics that has been produced since the 1950s has been thrown out. Mostly the number one most common plastic that has been discarded are single-use food items, but the second after that are in fact textiles. So this is sort of leading into our microfiber discussion. Next slide, please. For plastic pollution, both big and small, over 800 species worldwide interact with plastic pollution. And this is through different means. This is through ingestion, through entanglement in plastic, using plastics for nests, and ingesting microplastics. We see that hundreds of species have been recorded as ingesting microplastics around the world. We're seeing microplastics in our Great Lakes fish, and there are many species that are being added to this list of animals that are ingesting plastic. In our lab, we have fish from the Arctic, from the Pacific, from the Atlantic, from the Great Lakes, and we're finding plastic, especially microplastics, in almost every species that we look at. Next slide. And it seems that by number, microfibers are really quite ubiquitous. Our technologies have improved a lot in the last 5 to 10 years for quantifying microplastics, and we're going down to smaller and smaller size fractions, and microfibers are really coming out as one of the most common types of plastic pollution described in habitats around the globe. As we learn more, a lot of these microfibers that we think are plastic are other materials which could also have harmful effects. But we see microfibers in water samples, ice cores. They're in far places like the Arctic and mountain tops because some of them are small enough to float around in the air. agricultural soil, almost, you name it, wherever we look, essentially, scientists are finding microfibers there. And many of you have probably seen them yourself. They contaminate indoor air. So next time you are in an indoor room and sunshine is coming through the window, so you can see colorful specks of dust, often those are microfibers. Next slide. Microfibers also contaminate a range of different wildlife. They're ingested by wildlife in places as remote as the deep sea. Microfibers have been found in the Marianas Trench, which is the deepest part of the ocean. In seafoods, microfibers have been found to be the dominant particle type, and these fibers can also transfer between trophic levels in a food web, meaning that fibers are transferred to predators from the prey that they eat. Next slide. In the Great Lakes, I found a mean of around 25 microfibers per fish. And these microfibers are in the guts of fish, and we're finding them in the gastrointestinal tracts of alewife, rainbow smelt, and lake trout. And this work is still in progress, but we've found microfibers in every fish, and the majority of the microplastics that we're finding are in fact fibers. And an average of around 25 microplastics and microfibers per fish is quite high, but there are other species being studied in our lab that are looking at bottom feeding fish like bullhead, and they're finding as many as 200 microfibers per fish, and these are fish that are feeding off the bottom and in the near shore, whereas the fish I was looking at are mostly offshore, although they come into near shore habitats to spawn. But this just goes to show that the habitats probably make a really big difference in the microfiber accumulation. Thanks, Brooke. Next slide. So what about the effects? This is really the question that I ask myself, and it's one of the reasons why I was motivated to do my PhD. We know that microplastics can be a physical stressor when they're ingested. These plastics can cause abrasion, or animals don't get the proper nutrition that they need. We see this with seabirds, where chicks eat plastic instead of fish, and they can actually starve to death because they're not receiving proper food. Microplastics can also be a chemical stressor. There are chemicals added as ingredients to give plastics different properties, like durability, flame resistance, flexibility, and others. There can also be chemical byproducts. So when polymers are broken down into monomers, they can release certain chemicals. We see this with polystyrene, that when polystyrene is broken down into styrene monomers, there are compounds that can be released. And there are also chemicals, the last way is that there's chemicals that can be sorbed onto the surface of plastic debris. Many of these compounds are lipophilic, meaning that they're fat-loving, and can also be known carcinogens or endocrine disruptors, so they can easily transfer into the fatty tissue of wildlife when they're ingested by organisms like birds or fish in the wild. Next slide. And really what I'm trying to do, and I put a picture of myself here working in the lab, just because we're not able to present in person, but what I'm trying to do is understand the effects from these microfibers and understand what the physical and effects to different species are. And I'm working with many different students in this lab to answer this question. You'll hear more from Dorsa later about some of our work. Next slide. Still, there are very few studies that have tested impacts from microfibers, and I'm really interested in investigating what sort of impacts there are. What research has found is that exposure to polyester microfibers led to an increased mortality of Daphnia, the freshwater water flea. Long-term exposure of polypropylene has led to altered growth in lobster, and polypropylene has also led to changes in feeding behavior for crab. So this really meant there was a decreased food consumption and then less energy for growth, making these animals less fit. And of course, what we can do is apply to what we know for microplastics in general, but the effects from microfibers might be different because they have a different shape and they also have many different chemical compounds that they're associated with, especially because there are many chemicals used in the fashion industry, and many of these are held on fibers themselves. Next slide. And also not to be scary, but to also point out that microplastics are also getting into us. We've seen that drinking water, both municipal drinking water and bottled water, contains microfibers. Fibers are also in salt, in beer, seafood, and we don't know what the impacts are to humans, but what I hope this drives home is that the mismanagement of these fibers and our waste in general is really coming back to haunt us. And we need these better strategies to deal with our waste because they're now getting into us. Next slide. So connecting microfibers to a source. How did this all begin? Well, the first study to report fibers and link them to a source was by Mark Brown in 2011. He also did the first study in a washing machine looking at microfiber pollution. And because the proportion of synthetic fibers that were found in marine sediments and sewage also looked quite close to what we use in our textiles, this research group concluded that the fibers discharged from washing machines and into wastewater from laundering clothing were a likely culprit for these microfibers that were ending up in the environment. Next slide. And since then, a number of studies show that a single load of laundry can release up to hundreds of thousands of microfibers into washing machine effluent. And there are other sources of microfibers as well. We know that cigarette butts, carpets, dryers, fishing nets, and others also have sources of microfibers, but washing machines are really a big one. And when washing machine effluent is carried to a wastewater treatment plant, some fibers are released directly into aquatic ecosystems. A single plant on the Great Lakes has shown to release over 4 million microplastics in a single day. Most of these are fibers. Next slide. So as a pilot, what we wanted to do was investigate the effectiveness of two different technologies, both marketed to reduce microfiber emissions, and we did this in our lab. This work was mostly conducted by two really awesome undergrads, Haley and Jack, and they did loads of laundry, both with and without these devices. One device goes directly into the wash, the Cora ball, and the other an external filter. Many of you may be familiar with the Filtrol, and you'll hear about it later. It's quite similar in its design. Next slide. And what we did is we quantified how effective fibers could be mitigated from the wash. And here are results from our study that we published just last year. This is a box plot of our results showing the mean number of fibers per liter of washing machine effluent. And without either device, we found an average of around 5,000 microfibers per liter. Both devices reduced the number of microfibers that were in each liter of effluent and did so by an average of 26% for the in-wash device and 87% for the effluent filter. And what this showed is that filters, when they're added to washing machines, they significantly reduce microfibers that are shed from garments. And this means that when filters are added to machines, they really can cut down drastically the number of microfibers that are going into wastewater treatment plants. Next click. What we also did after getting these results is we followed up with an additional filter, the Filtrol, which you'll hear more about. This work was done in our lab by a PhD student that I'm working quite close with, Sam Athey, and she found that the Filtrol led to an 89% fiber reduction by weight in washing machine effluent, and it really works quite similarly to the lint lever, which is the other one that we tested. Next slide. Using results from our study, what we then did was we asked ourselves, what could the reduction in microfibers be at the municipal scale? And I performed a back of the envelope calculation and approximated the release for Toronto, which is the city where I live. And using the average number of microfibers shed in a load of laundry, multiplied by the average number of wash loads each Canadian household does in a year, and by the number of households in Toronto, we calculated that the release of microfibers could be in the order of trillions of microfibers per year. Next slide. And if we were to install either device in every single household across Toronto, then we would see that the number of microfibers emitted into wastewater from washing machines could be reduced by 6 to 9 trillion for the in-wash device, or 20 to 31 trillion for the effluent filter every year. Next slide. On to you.
Awesome. Okay, thank you so much, Lisa. So now that we kind of have a background knowledge of microplastics and microfibers and where they come from, this is kind of what sparked Divert and Capture in our partnership that started in 2018. So the three main goals of Divert and Capture are, the first is to physically divert microplastics from entering our water at the source. So this is the Parry Sound pilot project. Second is to engage the community with hands-on shoreline cleanups. And third, to provide the public with information on microplastics and practical tips to reduce plastic use. So I'm just going to highlight on part 2 and 3 of Divert and Capture, kind of before we dive back into the microfibers. But in 2019, we hosted 13 shoreline cleanups. We had 71 volunteers volunteer over 140 hours. We cleaned up nearly 5,000 meters of shoreline and collected 462 pounds of waste. With every shoreline cleanup that we do, we keep track of what it is that we are collecting. So you see the expected items, cigarette butts, food wrappers, balloons, but by a landslide, the dock foam was the most common particle that we found. So with this information, what we collected, we are in the process of conducting research on the impacts of dock foam in Georgian Bay. This research will be published in our newsletters and websites in the coming months. So we see the kind of large, the macroplastic, the larger dock foam pieces, but then we also really saw these really tiny pieces that are just challenging to collect. And then we also host these workshops. And this is kind of one of my favorite parts of Divert and Capture, the public outreach and the education side of it. We go to farmers markets, host workshops, attend conferences, webinars similar to this. And it's really fun to just kind of connect with like-minded individuals and how we can kind of all improve our actions and reduce plastic pollution. So shoreline cleanups and workshops are additional to the main research question being asked, and do these filters work at a residential scale, and can we see a difference in microfibers being released into our drinking and recreational waters? And the answer is yes. So Parry Sound is about 4 hours north of Toronto. It's on the shorelines of Georgian Bay. This community is home to over 6,000 year-round residents connected to town water. So we designed and started running this program in August 2019. We had with 100 filters in 100 people's homes. Since we know that these filters are effective in the lab, we wanted to test them at the residential level. So the only requirements that we had for people to participate in the study is they needed to be connected to Parry Sound town water. They had to have space to install the filter, and they had to agree to keep the filter running for 2 years during the duration of the study and capture the length that they were collecting. The image on your left is what the filter looked like, so you can kind of see the size of it. It is connected to your washing machine, and a fine mesh bag goes inside the filter to collect the microfibers. Depending how many people are in your household and how often you do laundry, it is expected that you'll have to clean out the filter about every 2 to 4 weeks. The image on your right is the Parry Sound wastewater treatment plant. So if you are connected to the city water, meaning that you're not on a septic, the water from your washing machine, shower, dishwasher is filtered through the wastewater treatment plant. And once it is treated, it goes back into the water source. So for Parry Sound, it goes back into Georgian Bay. We installed 100 filters in 100 people's homes. In Parry Sound, it's about 1,000 homes are connected to the municipal wastewater treatment plant. So we would expect to see an approximate 10% decrease in microfibers at the wastewater treatment plant. This is a timeline of the current of Divert and Capture. So it started in fall 2018. In January till July is when we signed up 100 households to be part of this exciting study. August 1st is when they all kind of turned on. And then October, we did a round of collection, and in February, and then this summer, we're hoping to do the third round of collection, and then continue with like workshops and webinars and hopefully some shoreline cleanups. I just want to say a huge thank you to the 100 volunteers. We have some really dedicated and enthusiastic volunteers who are really excited by this project and are really eager to kind of see the results that are coming out. The image on your right is a volunteer emptying out the bag. It takes about 5 minutes to clean the bag. And then on the left is a volunteer standing in front of his filter. So about every 4 months is when we do a round of collection. So in the morning, we ask that the household puts the sample in their mailbox, and we go around and collect 100 of the samples in one day. On the right is Erin from RBC holding 2 bags of collection. On the right is myself collecting one of the samples. This day is always really fun for the two of us. We kind of get to talk to the volunteers, make sure everything is working well, and see what their findings are. The first round of collection was just after Halloween, so you can definitely kind of tell who wore a sequency glittery costume a few days prior. So once we collect these samples, we send them off to University of Toronto to be analyzed, and this is what Dorsa will touch on next.
Thank you, Brooke. Hey everyone, my name is Dorsa and I'm an undergraduate student at the University of Toronto. I am really interested in the area of plastic pollution and climate change, and I've been helping Lisa with multiple projects in microfibers. So today I'll be presenting more of a lab side of things in the Parry Sound project and some of our preliminary results. Before we start, I wanted to show you a few photos of what it's like to work in the lab. So the picture on the left is what the fibers look like under the microscope. They come in so many different colors and textures, so you can see black fibers, blue, orange, and red fibers. On the right, it's a photo of me on a regular pre-pandemic day sampling at the Parry Sound wastewater treatment plant. So now let's dive into the super brief summary of lab methods and exciting results. So the next step in our journey after installing the filters was to measure whether these filters actually changed and hopefully reduce the number of microfibers. We tried to answer this question using 2 methods. First, we looked at the Parry Sound wastewater treatment plant. As Brooke mentioned, when the fibers leave the washing machine, they make their way to the wastewater treatment plant. So counting and measuring the number of microfibers in the wastewater treatment plant is a very important research question. The second method was to count the number of microfibers captured by the filters. So on the right, I have a photo of fibers separated under the microscope. They usually come in bundles like the photo that was before, but we have to use tweezers and tools to separate them out and be able to count them. Next slide, please. So here is what we did in the wastewater treatment plant. We went to Parry Sound both before and after we installed the filters to sample the final effluent. The final effluent refers to the water that has gone through all the cleaning steps and is ready to be released to the environment. We used pumps to drop the water into bottles so that we wouldn't contaminate the samples. As you know, the air and everywhere is just so full of microfibers that it's easy to contaminate the samples. As a bonus, we also took a walk on the frozen Georgian Bay, which is very beautiful in the winter. Next slide, please. The next step was to take the samples to the lab at the University of Toronto. We used sieves of different sizes to capture the fibers and particles. We used multiple sieves in case one of the fibers slipped through or something. There would be another sieve to catch it. We would rinse the sieves into little jars and count the number of microfibers under the microscope. Next slide, please. We had to take out the fibers one by one, put them on tape, and number them or ID them. The fibers in this photo are very small. The blue fiber on the right is probably less than 0.5 millimeters in length. And as you can see, they're very colorful. So we have blue fiber, purple fiber. I also had green and red. But the most common colors are white, black, and blue. Next slide, please. So here I have a brief summary of our results. This is a box plot showing the number of fibers per liter. On the left side of the partition line, you see labeled it as after filters. I have our August sample, which is after we installed the filters. And on the right-hand side of the line, I have before filters, which is July and March. So these are the samples before we installed the filters. And as you can see, from July and March to August, we see a decrease in the number of microfibers in the final effluent, which is very good news. We need more data points to be able to tell exactly how many and whether this trend will continue or not, but to put the importance of this decrease into perspective, Parry Sound wastewater treatment plant processes up to 3 million liters of water per day, and if we are able to reduce the number of microfibers in the final effluent by just even one fiber, we will be preventing the release of 3 million fibers into Georgian Bay per day. We'll be coming back in 2020 if COVID-19 permits to get more data points and see if this trend continues. Next slide, please. At the same time, as I mentioned before, we try to estimate the number of microfibers in the filters. Thanks to Brooke and Georgian Bay, we received the material collected in the filters, which is called the lint, about every 3 months. On the left, I have a photo of me holding one of the bags. We had about 100 of these, and they come in very different colors and shapes depending on how often people wash their clothing and what they wash. So we had to weigh all these bags and count the number of fibers and estimate the total by weight. Next slide, please. Based on our estimates, there were about 45,000 fibers per gram in each bag. That gives us an estimate of 1.5 to 6.2 million microfibers and other plastic particles captured per one household in 3 months of use. The range is variable because of how often people wash their clothing, but nevertheless, it is a significant number. And so far, we have been able to observe its effects by the reduction in the number of microplastics in the wastewater treatment plant. On the left, I have the full picture of about 5 milligrams of lint in about 1 centimeter by 1 centimeter square. So this is smaller than a dime. And you can see how densely packed the fibers are. In this little photo, you can find as many as 200 or 300 microfibers. Next slide, please. And another exciting news is the fact that they found other types of microplastics in our filters as well. So here on the right, I have a photo of a selection of types of microplastics that you can find in one's laundry. Glitters of many different colors. Glitters are microplastics, which is something I didn't know before I started my research. For some reason, they just don't get enough media attention. But we also found beads, fragments, and colorful pieces and paint. And so the bad news is that our laundry is emitting a lot of microplastics into the environment. But the good news is that these filters are able to capture most of them and prevent the release of trillions and billions of microfibers if they're implemented in large scale. And that is all for my section. Thank you for listening. I will now hand the mic back to Lisa and Brooke for the rest of the presentation.
Thanks, Dorsa. I just wanted to take a moment just to sum up. So what we see is that there's widespread microfiber contamination. This is both in habitats and wildlife around the world. We also see that there's contamination here on the Great Lakes. But as Dorsa mentioned, we can do something about it since we know that these proposed mitigation solutions are effective at reducing microfibers. And as a next step, what we could do is have filters put into all homes to reduce microfibers from washing machines. And the project here in Parry Sound with Georgian Bay Forever, it continues. We already have 100 filters in homes, and we will be installing 100 more when we're able. And for this next round, we already have about 3/4 of filters already claimed, but there's still some more spots available. So a quick plug, if you know anyone in Parry Sound that might be interested in a free filter, please do get in touch with us. And these filters are absolutely free to for the device and to install them. A more practical next step, when I really think about how we can solve this problem, might be to have filters directly installed into washing machines. And new washing machines in other countries, like in Japan, actually have these filters built directly into the machine, so it's something that is possible. There's also a need for legislation, like legislation recently passed in France. And this new piece of legislation requires filters on washing machines by the year 2025. And legislation is also being written here in North America. Right now, there's a bill proposed in California, also one in Ontario, and legislators are looking to the results of this study in Parry Sound to help write new bills that address microfiber emissions. So it's really exciting that we've gotten to get so much attention from just the small town of Parry Sound, and that really the world is looking at these results. And while we now have solutions for domestic washing machines, there's a need to investigate commercial washing machines and other sources. We also need to know the relative contributions of other sources of microfibers. We can help to look for solutions. And I think Brooke has a couple points next.
Thank you, Lisa and Dorsa. So I think this is a lot of information kind of that we've thrown at you today, and it can be a lot to process. So now we're just going to look at kind of now what can you do, and what can you do kind of starting today. So these are a few examples. We have talked lots about the filters. So there's the different options like the Coraball or the Filtrol 160 that we are using. But as Lisa mentioned, we're not saying that the solution is for every single household to put on a filter in your own house. But some alternatives to kind of reduce your microfiber waste in your laundry are to use full loads instead of half loads. Use reusable wool balls instead of the single dryer sheets. Use natural deodorizers like baking soda, and avoid the fabric softeners that contain toxic chemicals. Avoid fast fashion. Fast fashion are items that are typically only last a few washes. Invest in clothes that will last years, not just a few wears. Try to look for local sustainable items instead of these big box stores. And look for natural materials like wool, cotton, or silk instead of these synthetic materials. Think before you buy is a big option for you. So you as a consumer have so much power. If you're angry about the way your fruits and vegetables are packaged in plastic wrap at the grocery store, why don't you express that? Like, talk to your manager, talk to the manager, talk to the owner, talk to your local MPs. You have a lot of control of kind of what the future looks like for single-use plastic and fast fashion. So we just need to show that there is a demand and kind of look for those different alternatives. Another thing you can do is, I was mentioning all these shoreline cleanups. So these are things that we can do to clean up our shorelines of Georgian Bay, but also just whatever your morning walk is. If you see litter along your walk, pick it up. We do have these tally sheets, as I mentioned, that we do. We record everything that we collect during shoreline cleanups, and if you're interested in submitting what you clean up on your shoreline cleanups or on your walks, we would definitely be interested in seeing that. So you can just email me for one of these sheets if you're interested. But as I mentioned at the start of the slide, if you remember those single-use common plastic items in your house, there's lots of different ways to kind of switch and look for different affordable but also sustainable switches. So whether the kids, different toys, there's refilleries to go to, the shampoo bars instead of shampoo bottles, maybe a lot of restaurants now, you can bring your own takeout containers too, so you're not using styrofoam or plastic containers. I really encourage you to just start with one room in your house so it's not as intimidating. But if you start with your bathroom, you can kind of look for these shampoo bars, hand soap bars. There's many different options for you to kind of start with. I challenge you to think about every purchase you make in the coming weeks. Do your research. Does a local store sell it? Is there an option to make it yourself out of items you already have? Can you repair that t-shirt instead of throwing it out? Shop at thrift stores and donate to thrift stores. Bring a reusable water bottle. There's lots of these different kind of ideas that really, really do make a big difference. So you as an individual are making a difference. We do not need to be perfect, but every change you make is contributing to a healthy future for future generations. So that kind of concludes our webinar today. On behalf of University of Toronto and Georgian Bay Forever, we'd like to thank our generous donors and sponsors. This work would not be possible without you, so thank you so much. And then just on behalf of Lisa and Dorsa and myself, thank you for listening. We really hope you learned something new today. And if you do have questions, please put them in the chat box now, and we will answer them. Thank you so much, everyone. In your last presentation, you mentioned about working with manufacturers installing filters in their equipment. Any more on this? So maybe Lisa, you can touch on this.
That was manufacturers install, so washing machine manufacturers. Is that the?
I think so. Yes.
Yeah. So it is. It definitely is being talked about. Whether it will end up being that washing machine manufacturers will install them themselves and provide consumers an option to purchase a machine, either that has one, maybe you could charge a bit extra for a machine that has a filter already built in, is something that I could imagine. But I know Whirlpool is talking about it, but they haven't made any action. But I would also, on top of writing MPs, if this is something you care about and something that I've done and will continue to do, is reaching out to some of the manufacturers like Whirlpool and GE and requesting that these filters be built in, because the technology is there. It really will just take will from the company or some sort of legislation that will require the push. So I don't see any action on that in North America, but I know that they are talking about it, but I'd like it to go a little bit quicker.
So another question or some comments, I'll read this one. So what is the composition of the coral ball? Sometimes I wonder that if some devices produced with the aim to avoid plastic pollution are actually made of plastic, are they really worth the long term? Since at the end of their life, will they become waste themselves?
Yeah, that's a really good question, and I think that's something that I often think about are these regrettable substitutions. We often see them with chemicals, where you have a new chemical and it is replacing something, but actually we know that it is harmful. We see that with some BPA replacements, for example. The coral ball is made out of plastic. I can't remember the precise material, so I would need to get back to you on that. They actually retooled and changed the material that they were using, but it is a soft plastic that isn't really likely to fragment. So they did put a lot of effort into making it so it didn't shed plastics. It's made out of the same material that Crocs are made out of, but I can't think of it right now. And yeah, they're not as effective as the filters. They probably do something. I've heard from the creator of the coral ball that they might be more likely to catch fibres if you have a pet, and then your pet hair is kind of mixed up with the fibres. But yeah, it's not as effective as the filters. It's a great action, but it's really not the best for filtering out fibers. Oh, and I see another question. How long does the coral ball last? So it could last indefinitely, but you do need to clean the coral ball out. So it would collect collect fibers and hairs in the arms. It's designed after coral, so it kind of has these arms with very many holes and very many crevices that fibers and plastics could then attach into. Yeah, so I think it can last for quite a while, but not as effective. They're cheaper. I see another question, cost. They're cheaper than the filters. The affluent filters range from $100 to $200, whereas the coral ball is less. I think it's less than $50. So that's another big consideration. It would be a lot to ask everyone to retrofit their washing machines with a very expensive piece of equipment, and very expensive to install too, if you have to pay for a plumber to install it. Whereas the coral ball is something that you could just throw into the wash. So I really wish that it was as effective, but it seems like it still does something.
All right, so we're getting quite a few questions about septic systems and if these filters are effective on the septic systems. On the Georgian Bay Forever website, there is a really great article about kind of septic systems and these filters. I can recommend everyone to go read that. Maybe Lisa, if you want to if you have anything to touch on though regarding that right now.
On septic tanks?
Yeah. In
microfibers? Yeah. So sorry, I was just typing up that what the coral ball is made out of. It's ethylene vinyl acetate. I just thought of it. And so the septic tanks, there could be fibers that are caught in the septic tanks, and when you pump out your septic, it will go to a wastewater treatment plant for treatment. So there's still a way for microfibers to get into the environment, or it's possible that it could be going into soil through the drainage fields. There's not a whole lot that's known, but what I find really interesting is that it's how these effluent filters were first thought of, because someone in Nova Scotia had clogging in his septic tank, and it was clogging from lint, which are microfibers. So he just installed this on his washing machine. He's a really clever engineer and came up with it in his garage. And as researchers, we looked at this and said, wow, that actually, you're not just filtering out lint to prevent the clogging of your pipes, but you're actually filtering out these microfibers and keeping them out of the environment. So yes, there is like a strong septic connection to the history of these filters, and still, if you're on a septic system, you could still be contributing microfibers to the environment.
Great. So there's a question: how did you originally reach out to Parry Sound for the project? So this was done, I guess, last kind of winter and spring, the recruitment of the 100 households. It was done via newspaper articles, radio, interviews, kind of setting up at different conferences and things, postering around the town, working with our partners and social media. It was kind of easy to get the first, say, 50, but it was hard to kind of round up the next one, the full 100. But now we are having lots of positive reviews from the 100 volunteers, and they are really enjoying being part of it. And I think every volunteer is pretty shocked and disturbed of what they're collecting, because it's one of those things they just didn't know about. So I think everyone's really enjoying being able to kind of contribute positively to the study. But yeah, we do have a lot of different materials, whether it's on our website or on our social media, or hard copies that we distribute kind of throughout Parry Sound and throughout Georgian Bay communities. And then I think there was a question about outside of town, if you're interested in being part of the next 100 that we are installing. So the next 100 that we are installing, we're aiming for about 60% of them to be in town and a few to be on septic. So we are actually looking for a few outside of Parry Sound. So if you are kind of within a 15-minute drive of Parry Sound, and you are on a septic system and you do live year-round in your home, definitely get in touch with myself, and we can kind of discuss if that's a good fit and if you have space for the filter. How new treatment filters at wastewater plants reduce the amount of these fibers in wastewater effluent.
Yeah, so even systems that have tertiary treatment can still release microfibers. Really, what it relies on to remove all the microfibers would be a very fine mesh net that could capture them. Unfortunately, it would slow down the water too much. So it's a question that we ask ourselves a lot, is what's the most effective way to capture these microfibers? Is it at the source where people are washing, or is it the one, is that the one point where the water is then discharged into the environment? And I think, logistically, to have one filter that could then capture them all would be really effective. But it's everyone that I've talked to from the field is that it's really hard to retrofit these wastewater treatment plants to be able to filter them out, and also in the filtration process and in the first removal of the solids. Those solids are often land applied as a fertilizer. So most of the fibers are going to be captured in the phase where they're removing the solid material and then grinding it up and then using that for fertilizer in corn fields and other places. So when those solids capture up to 98% of the fibers, those are then still going into the environment. They might not be going into the environment at the wastewater treatment plant, but they're still being land applied, and then in a rainstorm, they can then wash off into creeks and streams and eventually rivers and lakes. So it's another way that these fibers get into the environment. But yeah, there are treatment options, but it's just that the issue is then retrofitting some of these facilities.
Are natural fibers a source of pollution? Can microfibers waste being considered in the well, yeah, I guess what are some examples of the natural fibers, and are they considered waste, and what are alternatives, I guess, to the synthetic?
Yes, so we know that yeah, in short, yes, natural fibers are still part of the problem. They break down a lot more quickly than synthetic fibers, but cotton and wool fibers can stay in the environment for up to a year. And since these fibers can have many chemicals associated with them, a study recently showed that cotton microfibers can have up to a third chemicals by weight. So since they're treated with synthetic dyes, finishes that make your shirts shiny or waterproof or flame resistant even, there are a lot of these chemicals that are then part of the fibers, and these chemicals too can be released to animals. Some of our early research is in the lab is showing that these natural fibers like cotton are having similar or the same effects as the synthetic microfibers, so it's definitely of concern. The great thing about a washing machine filter is that it would filter out both the natural and the synthetic fibers. So we're capturing everything at the source. And one thing I didn't know before I really started digging into this, but there's so many other materials too that have plastic components, even though they're not plastic. So for example, most machine washable wool is coated with a thin layer of polyurethane, and this just protects the wool fibers and is a common treatment that's done in the textile industry. So there could be small bits of polyurethane that comes off your clothes when you wash it, and there's no research on this, but it does make sense that the polyurethane would not just only adhere to the wool, and I would imagine that some of it would flake off. But yeah, again, there's no work on it, but as I learn more, I learn how many synthetic chemicals and finishes are applied onto textiles. So natural fibers, they are also of concern. Yes.
Great. So a question, can someone who doesn't live in Parry Sound have purchased a filter for their washing machine? So the answer is yes. As we kind of talked about different options in this presentation, there's a few different ones for you. Georgian Bay Forever, we are not a distributor or anything for Filtrol 160 or the other ones, so we aren't able to. I think they are selling them in Canada, but it is an American manufacturer, but you are able to order it. The price kind of varies, but it can be up to $300. So it isn't necessarily a cheap investment, but yes, you can purchase these filters. And then another question is, if we were to get a filter, what do we do with the collected fibers? Is there a place to recycle the fibers? That would be great.
There isn't. So there isn't a place. It's sort of now the best thing you can do is throw it in the waste, like you would what's caught in your dryer filter. It's very similar, what's caught in a dryer filter compared to what's caught in the washing machine filter. But maybe somewhere down the line, it would be possible to do loads of laundry and loads in a dryer that are a single material. So that material could then be recaptured. What becomes tricky is that the clothing that we wear is often blended. I think I have very few items of clothing that are only one fiber type. There's often a mix. So to then capture a mix of an unknown composition, it becomes challenging. But yeah, it would be really nice if it was possible to capture and then in some way reuse and recycle that.
Okay, so it's 3 o'clock now. I think we've kind of got through all the questions. So thank you guys so much for listening and asking some of these really great questions. It's really exciting to see the interest and care and passion that you guys all have, which is amazing.